So we're continuing from yesterday. We're still graphing rational functions. And what's the first thing I need to do to graph this function? What's the first thing I should find? Before I even do that? Domain. Let's find the domain. And how do I find the domain? Raise your hand. Set the bottom not equal to 0, right? That's right. What am I going to have to do with that bottom?
Square root.
No, not square root. Factor. Factor. So we're going to factor this. And I know that this is going to be x of x. And you remember, you ask yourself, what times what is negative 2, but adds to 1? Well, not negative 2 and 1. 2 and negative 1, right? 2 and negative 1. So what two things make up my domain? X cannot be what? X cannot be 1, and x cannot be negative 2, right? So far, is everybody okay? Okay, so let's do horizontal asymptote. HA. Hahova. Hahova. The horizontal asymptote. Now, you probably need to look back in your notes to actually help with this. Y equals 0. Okay, y, Justin. One more time, Justin. What was it? I'm sorry. Good. The denominator's degree is higher than the numerator's degree. Okay, and that's always going to be y equals 0 at that point. Excellent job. Okay, so now we look for holes. When do I have a hole? Let's just review that. When is it possible to have a hole? In the numerator. So the factor of the numerator and the factor of the denominator are the same. Well, here I've got an x, and down here I don't have just a regular x. I have an x minus 1 and I have an x plus 2. So those are not the same factor. Does that make sense? Okay. Let me give you an example here, real quick, in which there would be a hole if I add one more thing in. Okay? So I'm going to change the color so that we know to erase green here in a minute. But if this had also been x minus 1, x plus 2, and x, then I would have a hole at x equals 0, because that's on top and bottom then. That make sense? Okay, when it's the same thing, if I set that top equal to 0, what does x equal? 0. And if I set this equal to 0, that's also 0. So that would make a hole right there. Okay, let me give you another example. One more. Okay, and we'll erase it here in just a second of where another hole could be. If on top, this is factored into 3x times x minus 1, then there would actually be a hole at x equals 1. Does that make sense? When you see the same thing on top and bottom after it's factored. Everybody okay there? Okay. So in this case, is there a hole? No. So we'll write none. Now we do vertical asymptotes. How do I find those? This should be our easiest thing, right? They're my domain, right? They're the domain, but this time with an equal sign. Okay, before we go any further, guess what we're going to do? Graph. Graph what you have. So I'm going to graph y equals 0. I'm going to graph x equals 1. And I'm going to graph x equals negative 2. And now I have 3 pieces, right? Okay. And just so you know, here's how this works. I may have a piece that's here, and if there's, and let's say part of the graph's right here, then I know the other part cannot be down here. Okay? Let's say I have a piece here, then the other piece cannot be above it. But here in the middle it is possible that either it just comes down and goes back up, or there's also the possibility it comes down and it actually crosses. Because this horizontal asymptote right here is only for the outside region. Okay? And we'll see which case that falls into here in a minute. But what do I need to now find? X-intercept? How do I do that, Justin? Set the top equal to 0. So I'm finding the x-intercepts. That means y is 0, right? What? Say what you said. X would be 0 too, yeah. Okay. Now, notice then, I'll change colors so we can see it. I hit that point, right? That means, just so you know, this graph is going to cross over. Okay, so it's going to look like an x cubed graph is my guess here in the middle. And it's my guess because I've done this a few times now. So once again, this horizontal asymptote only really matters on the outside. It's allowed to cross if there's a middle region. Okay. Now I also need to find the y-intercept. How do I do that? Plug 0 in for x, so I'll plug 0 in. 0 over 0 plus 0 minus 2 is negative 2. Exactly. Hey, look. I already have that point on the graph, don't I? Okay. So what do I need to do to help myself out? X and Y chart. And let's see how we do with picking our numbers, because I think that's one of the hardest things is how do I pick the numbers? What number should I pick for over in this region? Brandon. Negative 1's not in this region.
Oh.
Negative 1's over in this region.
Negative 3.
Negative 3 and negative 4. Always give me 2 points in each region, at least. At least 2 points in each region. And if you're not sure, what should you do then? What if you're not sure exactly what that graph's going to look like? Do more points, right? Just do more if you need to. The minimum is 2 points. Okay, so use your calculator, plug in negative 3 and negative 4 at this time. So for the first one, did you get negative 9 over 4? I'll be honest, what I did to help myself out was I did the numerator, I did the denominator. I did not try to put them together. And then look, if I put a line right here, I get negative 9 over 4, right? Okay, so make your life easy. Don't try to be too complicated. So I have negative 9 over 4. Now, how many of you typed in what I typed in? If you type in what I type in, you can actually do this. Watch it. Are you ready? Second, enter. Second, enter. I'll change that to a 4. Second, enter. Second, enter. All my negative 3s, all I have to do is change those to 4s. I don't have to retype it. I accidentally clicked the wrong key there. Now I get negative 12 over 10. So I don't have to retype if I type it once correctly. I can just use the second enter key, and that pulls up the last several keystrokes. If you've ever noticed when I walk around, sometimes you're like, well, I deleted that, and I just click a few keys, and I'm like, well, here's what you wrote. That's how I'm doing it. Okay, so negative 12 over 10. Negative 12 over 10. Let's graph those. What is negative 9 over 4 as a decimal? Use that calculator. Negative 2.25, okay. So negative 3, I'm going to go down to negative 2.25, so a little bit below negative 2, right? Okay. At negative 4, what is negative 12 over 10? Negative 1 and 1/5. So at negative 4, I'm going down to negative 1 and a little bit lower. Do you know what that would look like based on just those two? Looking back maybe at the ones you did previously? Yeah, a lot of you probably realize, oh, it's going to look exactly like before, right? And that's right. It's not going to change on the outside. It's always going to be those types of graphs, unless you have a slant asymptote. We haven't had one yet. You'll see one later today yet. Okay, let's do the middle. Right now I've got 0, 0. What else do you think I need to plug in to help myself out? I'm going to do the middle. Negative 1, right? Let's plug in negative 1. Well, no, that's helpful to actually see. Okay, so we're going to plug in negative 1. And once again, I can do the top part in my head, so I'm just going to change the bottom part. And you could probably, if I said, okay, do the bottom part in your head, you could probably do that, right? But I'm just doing that to double check my math. So I got negative 2 for the bottom. And the top, if I plugged in negative 1, would give me negative 3. So I have negative 3 over negative 2, which is 3 over 2, which is also what decimal? 1.5. Okay. Do you want to plug in any more points, or are you guys okay there? What do you think? What's it going to look like? So I know it's getting closer over here, right? I know this one's getting closer over here, right? And then here, I just need to make sure I connect them with a curve. That's it. How do I know this one's going to go up? No, it was a good question. It's because it's actually closer to that line. And this one is closer to this one. Okay? So that was a very good question to point out to our audiences at home. Okay, we still need to do this side. Brandon, I'm going to give you one more shot here. Come on, you can do it. What numbers do you want? 2 and 3. See how 2 is right next to it, and then 3? Okay. Hey, we're determined. Brandon's going to get this one then. I'm determined. So 2 and 3. Go ahead and find those two answers. All right, what do we get for 2? Yell it out. 6 over 4. 6 over 4, 3 over 2. Either way, it's fine with me. Okay, 1.5 is perfect. What about 3? 9 what? 9 tenths. All right, let's graph that. So at 2, I'm at 1.5. And at 3, I'm at 9 tenths. Do I have enough to graph this? Yeah. Absolutely. Okay. So this one was more complicated because it has more horizontal, more vertical asymptotes. Okay. One thing to point out one more time. Anytime you have a middle, there is the possibility that it just comes and makes a U on either the top or the bottom, or that it crosses over. Okay? So here, instead of it actually hitting at 0, 0, it probably would have hit at 3/2. And then I would have known, okay, it's not gonna go down there. Okay? But since my X and Y intercept was right on there, I knew it had to cross over. Okay. Next problem. I know, bigger problem. Okay, and actually one that's going to hit on more pieces. So go ahead and glue another piece in. This time, like I just told the class, we're going to actually find the domain second because horizontal asymptote is easiest to look at when it's not factored. So let's find that horizontal asymptote. My favorite one because it's easy. What is it? It's what? It's not y equals 0. It's y equals 1. How'd you get that, Justin? If your degrees are the same, then you just divide your leading coefficients. So 1 divided by 1 is 1. That make sense? Okay, now, factor the top, factor the bottom. Let me repeat. Factor the top, factor the bottom. Well, you're asking yourself, what times what is -4, but adds to 0 since there's no x in the middle? That's a good question. Instead of just yelling out the answer, how about we give him, how do I find that?
You're welcome.
All right. Yes, yes. All right, now if I factor the bottom, that will factor into x plus 2. X plus 2, right? Okay, so first off, before we go any further, let's do domain, because I said we'll do it second. Well, it's second. What can x not equal? -2 and -2. I'm just going to write -2, if that's okay. You guys feel all right with that? Okay, so now we get to write the word holes. Are there any holes?
Yeah.
Where? At x equals -2, right?
Wait. Why?
Because technically there's 2 of them, but not for domain. Domain, you're only looking at the bottom. Okay? Now, since you found the holes, are you ready? You cross those 2 out for the vertical asymptote. Okay? So, vertical asymptote, where's that? At what? X equals -2, right? Interesting. This is going to be a weird graph here. Okay, where are you confused? Holes. Notice the top and the bottom were the same. So you set that equal to 0. What would x equal? Right? I'm looking for which piece matches which piece. If a piece matches, then there's a hole there. I don't care if the other pieces match. Yes. One on the top and one on the bottom.
And then there's 0 and 2. Like if they match that, you said that.
Exactly for the hole. They're both exactly the same, right? X plus 2 and x plus 2, aren't they the exact same on top and bottom? No, you're looking at what I crossed out here, buddy.
Yeah.
You're only setting that equal to 0 for the whole.
You find 2 that match.
You find,
That's it.
that's it. You find what's on top, you find what's on bottom, you find those 2 that match. And you set whichever one you care. I don't care which one you set equal to 0. Because they're the exact same, right? That makes more sense?
Now I'm not confused. It's very simple.
I took what was left of the bottom and set it equal to 0. For the vertical asymptote, you only set what's left equal to 0.
The top doesn't matter.
The top doesn't matter. You may want to write that. If you have a hole, you only set what's left equal to 0.
What do you mean on what's left?
What did I not cross out? The x plus 2 on the bottom, right? Vertical asymptote, you're only looking at the bottom here, Saka. Bottom. What did I not cross out on the bottom? Does that make sense? I'm trying to make sure we got it, okay? I'll wait. Correct. Yep. Okay, so I'm going to graph my horizontal asymptote at y equals 1. And x equals negative 2. And now we still need to find what? X and y intersect. So let's find the x-ins first. How do you find x-intercept? Set top equal to 0. Now, what is left in the top? X minus 2, so that would be 2, comma 0, right? So over here, 1, 2, comma 0, I'll put a dot. It was what was left over, Cheyenne, on the top. That help? Okay, what else do I have left? Y in? Oh. Because I counted over 2 from this instead of from where I was supposed to. Very good. Very good, Cap. They cost that I accidentally put it here. I counted 2 from there. That was a mistake. 2 comma 0 goes right here. Sorry, guys. Good call, okay? Okay, so now let's find the y-ins. How do I do that? Put 0 in for... Now, it's actually very simple. What's on top? Negative 4. What's the thing on bottom? So that's actually what number? So there's not a lot of work on that part. So the y-int is negative 1, comma 0. Oh, 0, negative 1, good call. How'd I get what? I plugged in 0 for x. Yep. Take that little bit of time to reflect. Do you know what the bottom part would look like? Yeah, you should, right? It's just going to look like this, right? I've got 2 points. I told you I need to see 2 points. Well, thank you, x and y intercept. You gave me 2 points. Now, how am I going to find the other one? Negative 3 and negative 4? How about this? If you are a girl, plug in negative 3. If you are a guy, plug in negative 4. Alright, so I plugged it in and I got 5 and 3. So I'm going to go to negative 3 up to 5. I'm going to go to negative 4 and up to 3. And at this point, I know what the graph looks like again, right? Okay. One thing I want to point out to you. Normally, if there's a hole, there goes an open circle there. But since my hole and my vertical asymptote were the exact same, the vertical asymptote wins. You put the vertical asymptote instead of the hole. Okay? So if it's a hole, let's say there was a hole right here. Okay? On my graph, I wouldn't be putting that lovely line. Instead, I would have put a circle there and connected it. That means the graph just doesn't exist right there. Now, it's not actually on this graph like that, right? Okay? But since the vertical asymptote was also at the same place that the hole was, the vertical asymptote won. Okay? Kind of like 2 people getting in a fight. You have a huge, huge person and a really tiny person. And normally who wins? Okay, never mind. I was gonna say, then I can't help you guys out. We'll just move on. Here we go. Here's our next and last problem. Tried to give you a little helpful hint there. Your asymptote is your big person. That's the one that should win the fight or win the battle. When I'm thinking small, I'm thinking like weak and thin, not like scrappy and fat. I'm thinking the thick, small-looking person. If that helps out just a little bit. Last problem. Last problem. Horizontal asymptote. Horizontal asymptote. So look back in your notes. You have to look at those notes to help you out. What is the horizontal asymptote? There is none. Okay. So notice there is none. So holes. In order to find holes, what do I have to do? Factor, right? Can you? Oh, okay, domain. What's the domain? Good. Not equal to 0. I set the bottom equal to not equal to 0. Which is that. Okay. To find holes, what do I do? See if the top and bottom, once it's factored, matches, right? Can you factor the top?
Yeah.
No. No, you can't.
Well,
Because there's a plus sign in between and there's no x in the second one. We're not going to be able to factor that. In fact, it's going to be imaginary numbers if you solve it.
Why can't you pull out a 3 and then...
Is there a 3 in both of them? That's why. It's kind of like if I decide I'm collecting homework and I say I'm only going to collect it from Stacko. Is that fair? He says no, but you guys take it. See, it's got to be fair to everybody. You got to take it from everybody. Okay?
so if it was 3x squared plus 3x.
Then I can pull out a 3.
Just general question.
Okay?
Now, why do you have a 3x squared minus 1? Is that fair?
No. If it had been, if they would be perfect squares with a minus in between, then I could. Okay, vertical asymptote. X equals 0. Now, this is the one that's different slightly. Because on day 1 of this yesterday, we learned also about this thing called a slant asymptote, didn't we? And that happens if the domain, if the top is 1 more than the bottom. X squared and x, so do I have a slant asymptote? So what do I have to do to find that? Something you guys don't like. Long division. So I'm doing it right now. So I put the x on the outside. I put the 0x in case I need it. If I don't need it, guess what? I just skip it when I get there. X times what is 3x squared? 3x times x is 3x squared. Change the sign and add. So I'm left with the 1, right? Does x go into 1? So this is my remainder, right? Okay, 1 over x is my remainder, right? That make sense? X doesn't go into 1, does it? No. So that's the remainder, right? I could bring it down 0x. Okay, and x times what is 0x? 0. You don't need a 0. Right, like we did on that worksheet. Alright, so, I'm sorry, we're not going to take questions for another 2 minutes because I'm going to finish this problem, okay? My slant asymptote then is y equals 3x. Only what I got on top, not the remainder. In this case, with a slant asymptote, the remainder means nothing at all to us. Nothing. Okay? So I'm going to plot my stuff. X equals 0. Vertical, right? There's no horizontal one. Now, this is a linear equation. y equals mx, what's my b? So I need to graph a basic linear equation starting at 0. And what's my slope? So I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. I'm also going to go down 3 over 1, down 3 over 1. You may be saying, Mizzy, why are you doing it so many times? Because I want it to go the entire way up and down this graph. Okay? I'm going to dot that, yep. So far, okay? Okay. So xnth, I set the top equal to 0, right? I'm just going to tell you now, I did that. And there's none because I subtracted 1, I divided by 3. That's negative 1/3. Can you take the square root of negative 1/3? No. So none. Y-nth, what do I do now? I plug in 0 for x. Can you have 0 on a denominator? No, so there's none there also. It is weird. Now guess what I need to do? I need to plug in points. And I'm going to plug in 1, 1, and see if it goes here or here. And I'm also going to plug in negative 1. So if I plug in 1, I get 4. And if I plug in negative 1 squared is 1. Times 3 is 3 plus 1 is 4 over negative 1. So that's negative 4, right? So I'm going to plot that 1 comma 4. Hey, look, I'm inside of there, aren't I? You see that? 1, 4 is inside of that little triangle. And 1, negative 4 is also inside that triangle. Weird, right? I know, you've got to ignore them. Now, I'm going to finish real quick. All that means then is I'm only inside those two triangles. I'm only inside there. This outside part, I never got to because only those points landed inside. Cool?